So, hello everyone. I hope you guys are okay at your house with the bad weather. Looks like it's a little bit better today. So, just wanted to make sure that you guys got all the information you need for Unit 8 in your midterm. Like I said in the announcement, next week is your spring break, and then the following week will be your midterm. So there's not going to be any change there. And I'm going to post two videos. This one that I'm going to post right now is I'm just going to show you where to access the information and then go over Unit 8. And then I'll post a more in-depth video of your actual midterm review and everything that you guys requested in your paper of what you wanted to review, and then things that I feel that you guys needed a little bit more work on. So that'll be a separate video. But first, I want to show you where to access the information. So if you go to your home screen and then you go to week 8, there's several things here. So if you haven't already accessed these items, the overview gives you what we'll be reviewing, the agenda, and then here is your homework for the week and the extra credit, which is 10 points. And on your extra credit, you have to complete all 3 pages in order to get the full credit. So 10 points is actually 10% of your midterm. So if you're concerned about your grade on your midterm, that'll be something that you need to complete. Then here you have the midterm presentation, which in Unit 8. So make sure you go through and review that. It's very important. We're going to go through it now, but it's important to go through probably all of these and quickly go over anything that you feel you need help with or anything that's on the midterm study guide that you need more in-depth clarity on. So if you click on the next item, which is the homework, it gives you all of the 7 pages that are due, and then the Unit 8 homework PDF. It's a lot easier if you work on the PDF rather than on paper. Then the next one is the same thing, but on the extra credit. So all 3 pages. Again, I'm not going to accept 1 page out of 3. You need to complete all 3 in order to get the 10 points. And then the quiz. And then, so since you guys weren't in class, the quiz won't be due until the 23rd, along with all the work. So here is the Microsoft document for you guys to access. And then there's 2 items here. This is on the section views, which we're going to go over now, but a really good reference, quick reference, couple pages on the different sections and how to read them, and then an overview. It's a very quick overview. So if there's something specific in the sections, a specific section that you need to quickly understand what it is, please review these, very important. And then lastly is the midterm study guide. And I tried to put everything on there that I felt you guys would need to know. And anything that, for example, on the terms, I put only the terms that I feel are going to be needed or necessary. So any terms or acronyms, things like that, that aren't on the study guide, I probably will not be on the midterm. So just a quick tip there. Okay, so going for the PowerPoint here on the Unit 8. Again, you have access to this. Please review it. And just a reminder that your Unit 7 homework, Unit 7 quiz, and your Unit 8 homework is all due on the 23rd, okay? On the 23rd is your next class. Next week, again, is spring break. Okay, so we're getting into section views now. Section views, we talked a little bit about this on the first day and when we talked about different types of lines, but section views give the viewer or the engineer or the machinist, whoever is looking at these drawings, a better view as to what's inside the part. So in this view, you have a countersink. And what you've been drawing recently is the top view, and then you have the front view. And on the front view, you would draw hidden lines showing where that countersink is. So now we're moving to a cross section. So basically, like we talked about in the beginning, it's like you're taking a knife through the part, you're cutting it in half, and then where the knife touched is where you have the section lines. Okay, and now remember where those hidden lines were are now changed to a solid line. Okay, so a big mistake and something that you see right here is that people forget to, you still have to show the solid lines. So However, the knife is not hitting this part of the countersink. It is shown once you cut through the part. So that would be shown. Just like you would with a hidden line, it's now turned into solid lines, and you have this cross section here. So again, so just a comment here, you never dimension to hidden lines. So you're never going to see a dimension to the hidden line. And like we said before, hidden lines will change to solid lines. So that's a good thing to remember, because if you knew if there's a solid line here or a hidden line there, most likely it's going to change into a solid line. So make sure you remember where on that right side view, or if it's a front view, you had hidden lines, and that would become solid lines. Okay, so another part or another line that we talked about was the cutting plane line. The cutting plane line tells you two things: where I'm cutting the part and where I'm viewing the part. So on this example here, you have a line, a cutting plane line going through. The cutting plane line is always the thickest line, or the most visible line. And then you have arrows pointing which way I'm viewing. So in this case, both sides are the same or symmetrical. However, you might have a different view on the bottom versus the top. So this is telling me I'm cutting section A, so point A to point A, and I'm viewing it from the top, or you know, I'm viewing this section, and that's what you see here, the front section. So hatching is added wherever the view is cut. So here's the top view. I'm cutting here, and then anywhere my knife touches or anywhere I cut, that's where I'm putting my section lines. So this is kind of an isometric view of what I cut. And then typically you're going to have center lines in your section cut, but almost never, I would say never, you're going to see hidden lines in a section cut. Okay, you're going to see solid lines. And then you're going to name your section cut based on the line. So this is section AA. It could be section BB, CC. It just depends on how many section cuts you have in one part. Okay, next is a full section versus a half section. So we're going to go through a lot of different sections. It's important for you to know the differences between the sections. This is definitely going to be on your midterm. This is definitely going to follow through the rest of the course. So make sure you know the difference and how to read them, really. So full section, it goes through the entire part. So that's what we just viewed. We viewed those on the last couple pages. So the cutting plane takes a part, and you're cutting all the way through the middle. And then you go, again, you have your line of view or line of sight. Okay, a half section shows half of the object in the section and the other half showing the exterior. Okay, so you can see a very easy description or view difference in this example at the bottom. So I'm cutting straight through the part. I have a full section. This is section AA. I'm viewing to the right. And then everywhere my knife touched, I have, you know, these section lines. However, my half section, in this view of this rotary part or symmetrical part, you have the B section, and then you have it going halfway through. Rather this A, when all the way through, it's cut half. So what that does is it takes two views into one. So at the top, I have this cross section where I'm showing what's inside. At the bottom, I have that typical right view. You know, this is typically, if I was drawing the right side of this, I would have a solid, and then I would have the hidden line showing what's inside. So, and then you can see here that there is no arrow. Okay, so you have one arrow showing my view, I'm showing this way, and then you have that it's going to the right with no arrow. So that's just telling you that the other part of the section, it's a half section, half is a section view, half is the right side view in this case. So half sections are limited to symmetrical shapes. This is because you want both sides to be the same. If you're giving two parts of information, say this other side is completely different, and you're showing a completely different view, it can cause confusion. So it's always going to be a symmetrical shape. So it's used where both internal and external features are shown as well. So you have, in this case, it's telling you, I have the internal here, and this is what it looks like on the exterior. Okay. So that's full versus half section. Now, in a little bit more detail, the full section. So the cutting plane is always shown, and like we just said, you're cutting all the way through the part. So this is just another view here. This is a typical part. I see this part a lot in examples. So in a 3D view, basically it's like you're cutting through this part and I'm removing this section and I'm showing you exactly what's inside. And these lines are telling you the dimension. So it's saying from here to here, typically you'd have a dimension there telling you the length. And then these lines, don't forget, these are hidden lines. These are center lines. Don't confuse the two. That's something you're going to need to know. But this is an example of what you would draw on the right side view, which you guys have been doing, right side view. Now you're doing a section, and I'm cutting this. Here's my view, and I'm taking it over to the right. So you have the same outline. Of course, it's the same part. Now I'm just showing where my knife is cutting. And then you can see in all of these sections, it shows at the center lines. Okay. And then in more details on the half section, this half section, you have the line, or you're being sectioned to the top here. And then this bottom, this one actually does have an arrow, but this is telling you that I'm viewing this part from the outside. So this, if I was drawing right section, or I guess this would be the front part, you would be given this view, and then I would draw something similar like this and draw my center lines. I would have hidden lines. And then on the left, I have my cross section. Okay. So it creates a convenient of inside and outside. I'm showing you the inside and the outside in one view, very, very easily. So that's what they're doing in both these pictures here. So another way to say it is half section views remove a fourth of the part. It's funny because half section is a fourth, but basically it's saying in the view I have only half is a section. Okay, so section lines or hatching. So we talked about this in chapter 1. So every different hatching, this is called hatching. The actual method of different lines is called hatching, okay? So section hatching are thin lines used in the view of the section to show where the cutting plane line has cut through the material. So each one of these represents a different type of material. It could be steel, could be nickel. It just depends on how the hatching is set up. Okay, and we'll go into what each one means. But if there's a question asking you what type of material is this, cast iron, whatever it might be, and you don't see it on your drawing, it might be in the cross sections. They're telling you, based on my cross section, this is the type of material. Okay, and we're going to go into each one in a moment. Okay, so the general use of default hatch material is cast iron, usually drawn at 45 degrees and spaced at 1/8 inch. That's a little bit more detail, more for like drawing or drafters. It's never horizontal or vertical. These are always going to be at an angle. Okay. And then you can also, it's just letting you know that they're all opposite. So if they're touching each other, it's just to lessen the confusion. Okay. All right. So symbology. So this is just a comment here. You're going to start seeing symbols in place of acronyms. So counterbore, if you remember, that was CBORE, right? And a symbol for that is this square, half square, upside down, or U, or however you want to see it. And then you have countersink, which is a V, a large V. And then you have the depth symbol, so saying this goes, say, 20 millimeters depth, whatever it might be. And then you have a square symbol here. Okay, so just, I would say the three, you're going to see these three constantly, probably in 80% of your drawings moving forward. So make sure you know what these mean. It's really important, especially when there's a question asking you, you know, what is the size of the counter bowl? What is the bore? What is the diameter? And you need to know, and you know, where is it? I don't see the acronym. I don't see a note. You're going to see a symbol. So just remember the symbols. Okay. Annular growths. So these are found on shafts and typically dimensioned by the diameter and the width. Okay. So, or by the depth from an adjacent surface. So you can see here, it's going to give you a note. Okay, 12.12 width by 0.12 depth. And then you're going to see, or you're going to see something like this. Okay, so these are two different ways to show the dimension. Now you have two types of grooves. You have the inside and the outside. And the outside grooves are actually called necks, whereas the inside are undercuts. Okay, so here you have an example. This is a undercut. So, and why this is important, you might have a question that asks you, what is the diameter of this undercut? It's important that you know what an undercut is and then where to find the diameter. Okay, two things there. And then same if I ask you a neck, the neck is this little indent. Okay, imagine this is a long rectangle part. This may go all the way through a rectangle. So this isn't just facing you. Imagine you're seeing a right side view and maybe it's a long rectangle. This neck would go all the way through. So there's an example on page 184 of this. So if you have your book in front of you, it's drawing 21A034. And then wall thickness. So this is just a comment here. So you need to know the wall thickness of a pipe, tubing, or any concentric diameters. You have to calculate the wall thickness by subtracting the inside diameter from the outside diameter. Okay? So you might get a question asking you, what is the wall thickness of this pipe? And this is the information you have. And you more or less have been doing this in your when you've been calculating dimensions. However, maybe you're only given the MMC or the min inside diameter, MMC. So how do you get that? You would take the maximum wall thickness, subtract the minimum inside diameter, so here minus the inside diameter, from the maximum outside diameter, MMC, and then you divide by 2. Okay, and then same thing, you would do minimum wall thickness, subtract the maximum inside diameter, the LMC, from the minimum outside diameter, LMC. So you can see common here is MMC by MMC divided by 2, or LMC by LMC divided by 2. Okay, so I think on your homework you're going to be asked a question like this to what is the wall thickness of the pipe? You're wanting to know the wall thickness of the pipe. Okay, so this is how you would get that information. Just reference back, this is in your book, and then reference back to these calculations. Okay, cast iron. Cast iron, there are 4 major classifications of cast iron. I believe there's one more, but that's not as popular, but these are the 4 that we're going to focus on. So cast iron is an alloy of iron, carbon, and silicone. And the carbon content is higher than steel, so it's from 2.5% to 4%. You have 4 different types, like I said: gray cast iron, ductile cast iron, or nodular, malleable cast iron, and then I believe some of you had a question, what is malleable? This is a view. It's just a different composite. heat-treated, white grader toughness, shock-resistant farm equipment. So, and then you have white cast iron. All of these are used for different types of things, different uses. For example, here it's not used for farm equipment. Here you have gray, which is typical for machinability and high compression. So just an understanding of what these are. A question you might have is, what type of cast iron is this? And you're going to find that in your notes, okay? In your notes on the drawing. All right, so spot facing. So this provides a smooth, flat surface around any hole. So the diameter in an abbreviation is SFACE, but you can also use that upside down or that like U-looking symbol that we talked about. That's also used. And then you would see the SF. So that's what you see right here, SF. Okay, and that's typical now. I don't see SFACE as much. I see more of the symbol. So make sure you understand that that means spot face, which is a smooth, flat surface around a hole. And one thing, people get a little confused and think between a counterbore hole and a spot-faced hole. So here's an example. So at the top is a counterbore hole, which we've discussed in spot face. Spot face is for a specific reason, again, just to have that flat surface. And then you see the examples here. So you just cut in here, you want it to be completely flat. And then the outside diameter has to be large enough to accommodate a fastener, washer, nut. So like here you have this rounded edge, and then you needed to accommodate for this fastener. So you had to create a flat surface, is what I did here. Here you don't have a spot-faced area, and you can see that's like up a little bit. Okay, so now different types of sections. We went over full, then we went over half sections. Now revolved sections. So these are drawn directly on one of the normal views. So all of these sections are to, one, show a lot of information in one view, and two, to save space. So in this case, you're trying to conserve your drawing space and show as much information as you can. So it's the same view that would have resulted from a cutting plane line passing through the object. So imagine I'm drawing that cutting plane line here, and instead of drawing it outside here as a section view, I'm drawing it right in where it would be, and then I'm drawing the cutting plane lines, or the break lines here, which is short break lines, as to where it goes. So this part could be, several inches longer, but they cut that off, one, to save space, and then two, it's honestly just a waste of space because you can show so much more information by removing that and just showing you a section view there. So in this case, you can show how ribs are radiused, and you can calculate the actual radius by dividing the rib thickness by 2. So this is revolved section, and typically all the revolved sections are going to be on parts similar to this. You're not going to see a revolved section in anything too complicated. It's going to be more or less this view. So the cutting plane line is imaged to be rotated 90 degrees, and the view is superimposed on or just outside the view. So that's what you see here. So the revolved sections are an efficient method to show the cross-sectional shape of ribs, spokes, arms, where a regular section view would be difficult to display. So here, that's what you see here. And again, you have short break lines, and then center lines are used to indicate the cutting plane. So this is where you have your center line. Revolved sections. All right, so broken out sections. These can get complicated. So the broken out sections are used only when a section of an object needs to have an interior exposed. So I thought the view on the top right is a good example. So basically, in my mind, it's like me breaking off a piece to see what's inside. In this, you have these short break lines in your view. So basically, I'm cutting this off and like seeing kind of peeking in to see what's inside rather than section cutting the entire thing. I'm just breaking it off on one piece to show you what's there. For an example here, they wanted to show you details of this area, so they broke this half off and then showed you what you're seeing. If I showed you just this view as a, say, front view, and I'm only seeing hidden lines, I wouldn't see all these details. So this just gives you a better description, because, for example, in some of the views you were doing, you know, it's difficult. I didn't really understand what was going on. This would be a case where I'm going to break it off to really show you what's going on. So there's a good example of this on page 194 for drawing 21A037. And one thing to note is there's no cutting plane here. You don't see any cutting plane. And this is because this section portion normally corresponds with an obvious center line. Okay, so you just see these short break lines and then the center line as to where the part is. Okay, here's another one. This one is called ribs in section. So when the cutting plane line passes flat along the rib or the web, resulting in a section view, will not include the section lines through the rib or web. So what is this saying? So this is quite interesting. So when you cut through this part, say you cut right through the middle here, if you cut through this part, you're only going to see at this very top, you're only going to see this, which doesn't really give me too much information, right? So, but if I cut and I want to see the rib, or if there's some specific information that I want to see, I would show the rib. So this avoids creating false impression of thickness or solid areas where the section is taken. So if you didn't see this isometric view and you only saw this view, it can cause confusion, right? Because you just assume that this part, I don't know, it could be, you have, you know, you don't know about these holes here, you don't know about these triangular pieces here. All you know is that, you know, you have an angle and you have a hole at the top. So it doesn't give you too much information. So holes can be rotated to show their geometry. This is called rotation of features, and then where cutting plane does not actually pass through them. So this is saying, yes, I'm cutting through here, but I might be showing additional information to allow the viewer to, you know, manufacture the part without confusion. So in this case, you see that this hole was not in the cutting plane line, right? You didn't see, this would have been here. So basically they added it here to show that information, to make sure that the viewer can machine that part accurately. Okay, so again, you never have hidden lines in a section view, so this is a way to show the information without using those hidden lines. So that's ribs in section. And then here's another view of that. So basically, like I was just talking about, if I cut right through here, it's not showing me that I have this empty space in the back because I can't show hidden lines. So a way to avoid that would be to add the ribs here to show that in my section. Okay. All right, so like we talked about earlier, there's a good selection of examples of these line symbols in your book, and you're going to see so much more on the internet, but you have cast iron, malleable iron, that's what you see here, steel, bronze, brass, titanium, electric windings, different things. So I don't think you guys, depending on what you work on, but we'll have to deal with the concrete or the earth or rock. It's going to be more towards cast iron, you know, you might maybe even white metal, steel, bronze, titanium. I would stay around those items. You might have, depending if you do molding, you might see, you know, rubber and plastic, maybe even cork, depends, or leather. And then you also have sand, different things like that. So knowing the important ones, I'd say A through J, D, E, and F, I would say are the most important ones, at least for our purpose. Okay, moving on to rotated features, which we hit upon just a couple slides ago, but rotated features are because sometimes the true position, okay, so true position being what you're actually seeing, the true position of the feature results in foreshortening ribs, web spokes. So a drafter will normally rotate to show the true shape. So what does that mean? So in this case, you observe the rotation of the ribs, holes, and other radial features. So we just talked about that when we on the last section, but you can see that this is going all the way through here. However, it's not showing that hole, right? And so what they did is they basically moved that hole over here for the section view. Okay, and it'll tell you on the drawing that it did that, and obviously you'll see that, okay, this section view did not cut through a hole. So you would see this would be an actual drawing, you know, you would see, okay, on my front view I see that the hole's over here, and then here's where I get the hole information is on the section. So we talked about that a little bit ago about rotating the features. So just making sure that you're looking at the whole picture, not just one view, not just this section. Make sure you look at both and correlate accordingly. Okay, next section is the remove section. So remove section violates the direct projection rule, and I can show you why. So before we were taking this part, making a section, and then just like you drew your multi-views, you had your front view, top view, right side view, and they all correlated, you know, correctly. Like you would have them exactly aligned. So in this one, the view is not in proper alignment with the related view. So basically, this is just me taking this section and I could even blow it up. Sometimes you see a different scale, which you do here. So you see that this is a lot larger. It's not correlating even in scale. So they blew these up to show you a specific section, a specific detail that they wanted you to show. So you have your say this is your top view. In your top view, it's showing you where I'm cutting. So you know where these sections came from. You have A, B, B, and C, C. But then it's going to tell you a scale, say 2:1, and it's going to give you all the details you need to machine that part. Okay, and these can be anywhere. It doesn't have to be at the bottom of your view. It doesn't have to be at the top. You can see these anywhere. And I think you've had 1 or 2 drawings so far that you've already dealt with that. So advantage of this is, so the remove section 1 can be drawn to a different scale, like we just talked to, and the size of the drawing sheet may be reduced. So if I had to draw each one of these to scale in the full thing, like say I did A, and then I drew the full part several times, it's going to take up a lot of space in my drawing. And I may have to do several different drawings to portray or show you what I want in the drawing. So this gives you the opportunity to, one, just put the top view there, and then to enlarge only the portions of the drawing or the section that I want to show the machinist or the viewer. Okay, so remove section, and another detail here, this is a good one. So the remove section is placed on the center line that extends from the imagery. So here I'm putting a center cut, and it's going to show you a cutting plane, and then it's just removed here. So I'm going to show you this view. This view gives you all the information. However, here I can actually show you the dimensions. Say I want to show you, you know, the width of this part. Now I can show you very quickly by pulling that out and giving you a remove section. Okay, and then here's another view. Say I only give you this view, but I want to correspond that this is like this cylinder type part, and then I can pull it out, and then it also can give you the type of material. So here you're it's telling you a hatch, so it's giving you the type of material it is. So it can give you a lot of information. Okay, so offset section, this is more common, I would say, than the half view. So this one is used when the internal features do not fall on a common plane. So here, instead of going all the way through, what they did is they cut through the circle, they moved up, and then they cut through the second circle. So now I can show everything that I need to show in order to machine the part. The one thing I want to note is, do you see where this line cuts right here? Some people will draw that down and then draw the line. That is not view. That is not in the view. You're not going to see that. So do not draw those lines down. So the offset sections eliminate the need for additional sections. So rather than me drawing one section here and then maybe one section down, I can draw both just by doing an offset section. And this offset section can be even like 6 different steps. You know, it's not limited to 2. It's just wherever I want to cut to show you what's in the part. Okay, so again, no hidden lines, and then I'm also showing a center line of my feature. And then here's another example here. Like I said, it can be multiple steps. So in this case, they went right through, and it's always through the center. That's one thing I want to say. If it's a circle, it's right through the center. So I'm going through the center, and then through the center, and then I wanted to go through the center of this hole. Okay, so if I say I drew it at the top of the circle, it's going to confuse the viewer as to what the size of the part is. So by doing this section, and then again it's telling me my line of sight is up, I'm able to know that this is countersink, counterbore, and then it shows me the diameter of this circle. And I had a 3D printed part to show you, but I can't show you. I might be able to maybe post a picture later if I can find it. And then here's another view, a 3D view or an isometric view here. And this time they did 1, 2, 3, 4 steps and even came back down to show you this hole. So when drawing this, again, these correspond just like you would do on your front view. This is your top view. Just like you would show on your front view. It lines up exactly. And then if I had a right side view, which sometimes you do, maybe they replaced their front view for a section cut, my right side view would line up exactly with this view. And here I cut through, I have a countersink, counterbore, counterbore, countersink. So it gives me all of the information I need in one view right here. And in this case, they replaced their front view with a section. Okay. Okay, so that's sections, and there's a lot to sections. So I encourage you to look at the 2 handouts that I posted that we covered over in the beginning of the meeting, and then also review your book. It's important to go through your book, and when a lot of you need to read the directions. Make sure you read the directions, but typically with the directions is some help. You know, sometimes they give some hints, and so make sure you're reading that. So for Unit 8, just quickly go through the presentations if you need to. Review the 2 handouts that I had posted. Read your book, and then I'll post a discussion board, and if you have any questions on Unit 8, let me know. And then you have the homework on the 7 pages, extra credit opportunity. Again, you have to complete all 3, and then the homework will be due actually on the 23rd, not the 17th. Okay, so this definitely will be on your midterm, units 1 through 8. Section, it's very important that you know sections. So my way of understanding is, again, imagining you're taking a knife, you're cutting through a part, and then anywhere the knife touches is where you would have section lines, and then anything you don't would be a solid line. So really important for this information. So I will post another video eventually on the midterm. So you have all next week, and then most of the week, the following week, to really study. And I also will post some practices because a majority of the work is not coming from your book. So a majority of what is on the midterm is not from your book. So I want to make sure you're familiar with how it's going to be presented on the midterm. So I'll post that as well. So be looking out for that here in the next few days. Okay? All right. Good luck, guys.